Okay, so transitioning to our presentation today, design and implementation of interactive learning. We'll be talking a lot about cooperative learning strategies and framing today's presentation by major shifts in engineering education and the principles of how learning works. So our guest speakers today, Dr. Karl Smith, who is an emeritus cooperative learning professor of engineering education at Purdue, and he is also an emeritus professor of civil, environmental, and geoengineering at the University of Minnesota. And he started his academic career as a materials processing engineering researcher and changed his focus to engineering education research, where he focuses on building research and innovation capabilities in engineering education, faculty and graduate student professional development, and the role of cooperation in learning design. There's a lot of other information there. He also has a really great website with more information on him, his background, the books he's written, articles, lots of great resources too open. So I'm going to put that at the end of our slides as well and would recommend checking that out. And then me, myself. So I'm Dr. Kristen Pena. I am currently the Senior Program Manager for Learning Initiatives here at the Fulton Schools of Engineering, Learning and Teaching Hub. And my research interests have focused on faculty professional development and faculty-student interactions. And so with that, we will go right into our presentation. Okay, so welcome everyone again. Here is just a high-level overview of our session today and the agenda. So we're going to frame things first with some of the major shifts in engineering education, talk a little bit about how learning works, and then thinking about alignment of outcomes, assessment, and instruction. And then we'll dive more into cooperative learning, so the different types of this kind of learning. I also wanted to mention this will be a little bit of an interactive session, so we will have an opportunity for small breakout rooms. There will be a minute paper at the end, but again, feel free to use the chat to pose any comments or questions, and we hope at the end we'll have some time for a discussion as well. Thank you so much to everyone who completed our pre-survey as well. We did have a small number of respondents, but from this we can sort of see we have folks reporting that they are either very unfamiliar or a bit familiar with the neuroscience of learning and how people learn. And then the other smaller graphs here on this side, we have more folks reporting that they have some or a lot of awareness or understanding for aligning of student learning outcomes and assessment strategies. And then the same with interactive learning. So thank you to all of you that took the time to do that. That was important for us as we sort of prepare and connect this for you all. And then we also asked this open-ended question. So what did you want to get out of this session? So here are a few things that were shared. So new strategies, especially considering today's students, thinking holistically about the learning experience, so mental health aspect. And then here in our context at ASU, considering large or online classes as well. And then some folks are still learning. So like the like art sale showed, some people are coming from a place of learning and just wanting to learn more. So we will talk about specific strategies. I hope one or two of them are new. And many can be applied in online courses and with large enrollment classes as well. We'll also talk a little bit about how people learn, and a part of that is connected to mental health, students' emotions, well-being. And then I'll also say that Karl very graciously offered to meet with folks in the future outside of this. And so if you still have questions, want to continue the discussion, I'll talk a little bit more about that at the end and how you can do that as well. Oh, bless you. Bless you, Jen.
Sorry about that.
It's okay.
I wasn't on mute.
It's okay. All right. And I'm going to turn it over to Karl to talk about this one.
Well, thanks, Kristen. It's been a delight to work with you, and welcome everyone. Good to have a chance to interact with you. As Kristen said, I'm an emeritus faculty member. I had the privilege of serving for 50 years. I made the 50-year mark, which is quite an honor. And also, as she mentioned, I'm a champion of evidence-based instructional practices, especially interactive learning and building engineering education research capabilities, really turning the spotlight on us and studying ourselves. A little over a decade ago, then Dean of Engineering at Purdue, Leah Jameson, asked me to write a piece for the centennial issue of the Proceedings of the IEEE on major shifts in engineering education over the past 100 years. I've been thinking about this and speaking about it, and so I sketched out these 5 areas of major shifts. I was talking with my colleague Phil Wonkat about this writing project, and he is doing a similar project around chemical engineering. So we worked together on it, and then as we continued, it occurred to us that this is an electrical engineering publication. Maybe we should include a double E. So we invited Jeff Freud to join us. And we'll elaborate more on these, especially the second, third, and fourth one, outcomes, design, and the social behavioral sciences, and how they inform this seminar. I also did an update on these recently for the National Academy of Engineering. Their practices for engineering education research, education and research is really thinking a lot more about engineering education. So in thinking about the second shift, outcomes, in 2000, ABET shifted the accreditation of engineering programs from input-based to outcomes-based. And my colleagues and I, and Kristen and I have embraced this idea, and we are arguing that it's not only important at the program level, but actually at the course design level, to really think carefully about what is it you want students to know, what do you want them to be able to do, who do you want them to be as a result of your course. And really thinking about what Ruth Strebler and I call enduring outcomes, those outcomes that you really want to have around a long time after the course. And we're going to encourage you to really think about enduring outcomes. And then in the next slide, aligning those outcomes with assessment and instruction. And again, we would argue that it parallels the engineering design process, and it's just good engineering to use an engineering design process for course and program design. We agree with Jim Duderstadt, who had many, many roles at the University of Michigan, unfortunately passed this past year. But he argued that we really have to set aside our roles as imparters of knowledge, i.e. teachers, and become engineers in the learning process, and that is designers of learning experiences, processes, and outcomes. And that a lot of that's what this session is about, really thinking about designing learning experiences. 3 years ago or so, Ruth Rocio Chavella, who was then at ASEE, American Society for Engineering Education, and I revisited these shifts in a webinar called Learning in the Time of Coronavirus. And the piece that we added was really thinking about the implications, which are what's emerging in our seminar today that Kristen and I are doing. And also, due to the pandemic and the very rapid shift to remote learning, we identified a couple emerging shifts, the shift to remote learning, and a shift that had been occurring for some time, and that was really embracing inclusion, diversity, equity in learning environments, and more broadly. So the next shift, which has been occurring throughout the past over 100 years, as research has been conducted. Some of it's showing up in engineering education, and that's been happening for quite a long time. What Kristen and I want to highlight, though, is the implications in 2 domains. One, the cognitive domain, and secondly, in the affective domain, which is often neglected in engineering learning environments. In the cognitive domain, we know now quite a lot about how people learn. There was a major report from the National Academy's National Research Council in 2000 called How People Learn, Brain, Mind, and School. which really summarized what we know or what we knew at that time, 25 years ago. And since then, there's been an emergence of a lot of work on the neuroscience of learning. The other piece that informs what we know about how people learn is the importance of interactive learning. So in focusing on the neuro piece, it's very clear that learning requires deliberate, distributed practice. In other words, it has to be intentional. You really need to be deliberate about it, and we need to be mindful of the cognitive load, i.e. the bandwidth. And it's very clear that feeding information like a fire hose is not a real effective for helping people learn. The neuroscience perspective also notes that we need to provide opportunities for reflection and opportunities for learners to process the information, for it to become internalized. We've known for a very long time that distributed practice is better than mass practice for learning. Yes, one can cram for an exam the night before and maybe do okay on the exam, but not much of that knowledge sticks around. Whereas if it's distributed over time, it's more likely, and that's been demonstrated for, gosh, almost 100 years. We also would argue that multiple modes of input, audio, like what we're doing, and visual, and then we will do some interactive so that we have kind of multiple modes. And then the third key piece is practice with feedback. And we've embraced, on the next slide, your colleague Mickey Chee's framework for practice. She calls it the ICAP framework. And my understanding is that Mickey has worked with you presented in this seminar series. So many of you probably already know this. But her work, it makes a very compelling case that interactive learning is more effective than constructive, which is more effective than students just being attentive. And having learners do pretty much anything during class time is more effective for learning than having them sit by passively. One key finding of the importance of interactive learning is it reduces failure rate. This is a meta-analysis Scott Freeman's group at Washington did. It's published in the Proceedings of the National Academy of Sciences. It's freely available, a lot of data. And that study showed that having students interact during class time can reduce the failure rate by more than 10%. You have evidence on the ground at Arizona State in a variety of settings for this. The work in mechanical engineering's thermodynamics course that Ryan McCarrick has led, the peer-led study group, shows a similar reduction in the failure rate. And in effect, especially for first-generation students and transfer students. It turns out Ryan was a transfer student. And the other broad area where there's a lot of evidence for the importance of thinking about education, social and behavioral sciences, is in the affective domain.
Yeah, so when we talk about affective domain, we mean students' emotions, attitudes, motivations, and values. And so while this has probably always been a part of learning, we think it became especially apparent during the shift to remote learning that we saw during COVID. So suddenly students were struggling not just with content, but with motivation, with their emotional well-being and engagement. There was a lot going on there. And the affective domain isn't separate from cognitive processes. It directly influences attention, memory, problem solving. So if students are anxious or disengaged, their ability to retain information and think critically is effective. And this sort of ties to Maslow's hierarchy of needs, which reminds us that students have to feel safe, both physically and psychologically, in order to learn. So support can come both from the academic side and personal side. So students who feel supported are more likely to take risks in their learning and push beyond their comfort zones and persist through challenges. So academic support can look like resources offered during office hours or tutoring and study groups. And these tools help reinforce their mastery of concepts and skill development, and then personal support as well. So equally important is genuine concern for student well-being from both peers and faculty. So when students feel seen and valued, they're more engaged and more motivated. So knowing they have this strong support network, both academically and personally, just allows them to challenge themselves more and attempt higher level tasks and persist through difficulties. So now we're going to take a few minutes to do that small breakout room that I mentioned, for you all to pair up and discuss your experience with interactive learning as an undergraduate student. So we want you to think back to your experience. When was the first time that you encountered interactive learning in a class setting? Maybe it was the first time you heard the term or the first time that you were asked to work with others. So I'll let you all take a moment to think individually about that before we put you in breakouts. All right, welcome back, everyone. Um, I know that was very short, especially if you did have a really great experience or a bad experience, I suppose, that you were commiserating on. But if you all could take a moment, just type up a quick takeaway, something that was interesting or insightful from the conversation you had, and share it in the chat. Then we might call on you to share a little bit more if you're okay with that. Well,
And
thank you so much, everyone.
yeah, thank you. And it looks like folks actually have had experiences, which is encouraging. Because I didn't. I was in engineering school in the 60s, and this is the only model I ever saw throughout undergrad and graduate school. And so when I took a job at the University of Minnesota, I was hired as a researcher, and I wasn't planning to teach. But after a couple of years, there were some changes, and I wound up in a third year classroom. And I used this model, and it didn't work. Students asked questions that indicated they had no idea what I was talking about. And it was really discouraging. And I know from working with hundreds more early career faculty members that several early career faculty members have found that what they try to do doesn't work that well with students. And interestingly, I think because of my experience working as an engineer in industry and as a researcher, rather than blame the students and say, well, send me better students and I'll do a better job, which we sadly still hear today, I thought there has to be a better way to do this than what I'm doing. And I started taking courses in the College of Education at the University of Minnesota. And oh my goodness, I found that somebody actually knows something about learning, about motivation, about development. And then I took a course in social psychology of learning where I experienced this model. So rather than, pour it in, the idea was keep it flowing around and connect the students and interact with them and involve them. The instructor still plays a central role. This is the cooperative learning model. It's the way I worked as an engineer on the job. It's the way I worked as a researcher. We worked on big problems with common goals, but we had to take individual responsibility. And I started using this in my classes. I also started doing a systematic experimentation. And on the next slide, you'll see that I introduced, oh no, I forgot about this. The question about a cooperative versus collaborative. It comes up regularly, and Kristen was pretty confident we'd come up here, and so we decided to address it. There's a lot of similarities. They're both grounded in social interdependence theory. That's the big idea for both. But there's differences in terms of the structure. Cooperative learning is much more structured than collaborative learning. They both have a place, and and it just takes sometimes a lot more guidance to help students work collaboratively where there isn't a lot of structure. And engineering faculty are more likely to embrace an area where they play a more significant role. So in 1981, I introduced cooperative learning to the engineering education community in a Frontiers in Education conference and in a Journal of Engineering Education paper. It wasn't greeted with great enthusiasm because it was quite different from what most people were practicing. But I came with data, and I came with a pretty compelling theory, social interdependence theory. And over time, it's gotten embraced much more extensively. Probably the most comprehensive piece on cooperative learning in engineering is that 2005 piece in the Journal of Engineering Education called Pedagogy of Engagement. It's been cited over 2,300 times. It's publicly available. So if you want to take a look at some of the evidence that it's available. On the next slide, this is the definition of cooperative learning. Instruction that involves people working in teams to accomplish a common goal, and that's a key piece. That's the social interdependence piece. There needs to be a common overriding goal, and often in a learning environment, that's a learning goal. Let's ensure that everybody learns. It's sometimes a common task, like with capstone groups and things like that. And then there are two key conditions that we're in it together: the positive interdependence and individual and group accountability, which can be operationalized, like we were discussing earlier, by randomly calling on people, by doing individual exams, by structuring roles that have accountability. And on the next slide, there's a handout that has a specific list of ways of implementing interdependence and accountability, as well as the other evidence-based key elements of cooperative learning: the promotive interaction, teamwork skills, and group processing. If this is something that you might find helpful, you can download it. There's a link in the resources. I see you nodding, Kristen. So where will they find it?
Yeah, so you can get it directly from here, and I'll download that PDF also and upload to our folder.
So in case you're wondering, why should we bother emphasizing cooperative learning? We alluded to this earlier, that more students learn more, remember it longer. I would also argue that it's an essential transferable skill. And, for years now, employer surveys have argued, please, the technical skills are fine. Please send me people who can work with others and who can communicate effectively. Those are transferable skills. There's an enormous amount of research on cooperative learning summarized on the next slide. It's a pretty busy slide. There have been studies going on for over 100 years, I guess slightly over 100 years. The first systematic study in engineering education was done by Morton Deutsch at MIT. It was published in 1949. And so, this work has been around for a while. I've been involved in a variety of publications that summarize the outcomes. More students learn more, remember it longer. They develop enhanced critical thinking and higher level reasoning skills. They develop teamwork skills. And ironically, they often note that they like the subject more if they're working with others to learn it. Next slide is a meta-analysis that was done in the 90s. Because one of the concerns after the work we did in the 80s was people would say, oh yeah, that's the higher ed research. What about my discipline? Science, math, engineering, technology. And so Jim McGregor, Jim Cooper, and I were able to convince folks at the University of Wisconsin at Madison, at the National Institute for Science Education, to commission a meta-analysis. It was published in a report form in 97 and in an article in 99. And, the same result. Greater achievement, these are, it's called effect size. It's the standard, it's difference in means and standard deviation units. And, similar to the reduced failure rate that we mentioned earlier, it showed up here. Also, higher achievement. So, and enhanced persistence. So the data are there, but of course we know the data isn't sufficient to get folks to change their practice. This is a National Academy study, Education for Work and Life, about transferable skills. Again, this is a report that's downloadable. It articulates skills like communication, teamwork, and their importance for lifelong success. There are three main ways to structure cooperative learning. You're experiencing one, and Kristen will elaborate a bit more on it.
Yeah. So, what does this look like in the classroom? So, thinking about our students today, about what we know about attention span research and the benefits to all learners, and thinking about multiple means of engagement and checking lessons and lecture delivery. We'll first talk a little bit about the informal cooperative learning strategies. So the bookends approach is a way to think about structuring a class session and adding a few interactive learning strategies throughout. So this usually starts with an engagement activity or an advanced organizer. So a question or a task that sort of sparks the participants or the students' curiosity and helps you discover what they already know about the material. So we did that with a pre-survey to you all that we sort of talked about the results of at the beginning. And then the middle is this back and forth transitions and chunked lessons and putting in activities in between. And the final bookend is a minute paper or a muddiest points survey, some way to sort of guide the class in a reflection. And there's a few examples of some questions you might ask as part of that. And we're going to be doing that also later on. The advanced organizer, really understanding what students already know is important. So again, we did this with the pre-survey, asked you all what your awareness and knowledge on a few topics that we were going to cover today so that we could make sure that we were hitting on things or adjust accordingly and really connect it to your past knowledge. And then we did our small group discussion too. So this formulate, share, listen, create is a lot like think, pair, share. It's connected to the ICAP framework that we talked a little bit about. But the importance here is the interactivity is really impactful. So it goes just beyond being active or paraphrasing or that individual self-creation, but having you all work together, having students work together to co-create something. So when we asked you to share your group's takeaways in the chat, hopefully there was a little bit of a conversation on what that takeaway was so that you're sharing something that you co-created together. And here are a few examples that you could use for a focus question. And again, the intent here is to have them learn from and with one another. And if you're interested in going through a more structured planning form on any of these strategies, there is a really great worksheet on Karl's website, and we'll add it to the resource folder and linked here in the slides too. But it just sort of walks you through thinking about those informal cooperative learning strategies and how to add them.
So that was a summary of informal, and it's where many engineering faculty start because it doesn't take a lot of time. It can be interjected at any time. For example, if you look out there at the learners and you see a confused look on students' faces, which sometimes occurs, actually probably occurs fairly often, rather than ask, are there any questions? Which I would argue is a useless question because very few students are going to say, well, I have a question. I'm lost. I have no idea what you're talking about. Instead, ask them to think about what they're not so clear on at that time. Ask them to reflect on it, like Kristen asked you to reflect on your experience with interactive learning. Ask them to turn to a neighbor and share the question that's uppermost in their mind, and then ask if there are any questions. And I can assure you that it's much more likely that someone will say, "We have a question." Um, and there's just a lot of security in that. It's not, "I have a question." I'm terrified of looking foolish in front of my peers. It's, "We have a question." And you often get very good questions that way. And it can be short-term and ad hoc. It can be used to break up a long lecture. That's based on the attention span research. And this is where the processing piece comes in. It's called cognitive rehearsal, gives learners a chance to process the information. Especially effective in large classes and one-time events like this guest presentation that we're doing. Um, the bad news is it's not the best that we know how to do. The best that we know how to do is formal cooperative learning groups and base groups, which we'll just very briefly say a little bit more about. So formal are very formal teams. They're pretty highly structured. Um, some of the key elements of faculty decision making are on the next slide. Um, being very clear about the objectives, especially for enduring outcomes. Those outcomes you want people to really know, be able to do a whole bunch of decisions. How big do you make the groups? How long do you leave them together? Um, on and on. You structure roles. Make sure there's a challenging enough task, or there's a task where you can do a division of labor that it actually merits a group. Some resistance to cooperative learning and group learning in general is students have been in make work groups where one person does most of the work and others share the credit, and that's a waste of time. So make sure that there really is a compelling need for a team. Capstone groups are a prime example of that. On the next slide, there's a link to a recent chapter that Rich Felder and I wrote, Cooperative Learning and Engineering, where we summarize the most common formal cooperative learning approaches that are used in engineering. And there's also a link to the draft in case you don't have access. Your library probably has access to that chapter. This is a Routledge publication. And the
Great.
third, cooperative learning groups, cooperative base groups.
Yeah. And if it isn't available through our library, we can request it. So, yeah, a next book study book. We run a book study also. So we'll add that to our options list, Marty. So cooperative based groups. So these are long-term stable groups designed to support a member's academic and personal development beyond class activities. So these groups foster accountability, skill building, and mutual support over an extended period, either a semester, a year, or beyond. So similar to base groups. So I was in a cohort-based model for my doctorate program. So we formed a consistent support system through these groups. So we did go through the same courses together. There was that academic support, but beyond that, it was the navigating the program and career opportunities. It was the emotional support or personal challenges that we found ourselves supporting one another in. And even during our final year in that program, we sort of self-created our own writing group. So we were all writing our dissertation. And so there was a structure for this in the program, and our dissertation chair did provide some guidance on it, but it was really up to us to make the group our own. And each cohort group within that program looked a little different depending on each group. So cooperative based groups engage both in academic tasks and interpersonal growth. They regularly reflect on their progress and challenges. They create a sense of belonging through the academic and emotional and motivational support. They promote a shared responsibility for learning and task completion. They set mutual goals and expectations with group members and hold each other accountable. Like I mentioned, these are self-directed. So groups self-organize their meetings and activities and set their goals. But the faculty do provide that initial structure, periodic check-ins, providing guidance to the groups, and sort of act as a resource rather than micromanaging the activities.
I'd be curious, Kristen, at how many of our participants have been involved in a study group or a base group. Raise your hand if you've been part of a long-term study group or cohort group. I wasn't as a learner, but as a faculty member, I taught in the Management of Technology program. It's an MBA-like program for technology folk. And all of those participants, is a 2-year program, met one day a week, alternating Fridays and Saturdays. They were organized into a study group that were encouraged to meet every week. And a very, very common comment at the end of that experience was, I would not have succeeded if it hadn't been for my study group. So these can make a real difference, as Kristen has articulated. I see been a few hands up. I didn't see a huge collection of hands, so a few of you have had these experiences. To summarize, I've been arguing for over 30 years that we're really in the midst of a paradigm shift in higher education. Bar and tag, from teaching to learning, the best known reference here. But I and my colleagues have been, thinking about this too. And it involves how we think about knowledge, how the role of students and faculty, the climate, the context, and we're advocating, the newer paradigm is a cooperative context. And the old paradigm was that, well, if you have a PhD, you can teach. And that teaching is complex and requires, seminars like this and learning more about learning and designing instruction. A couple of recent reports. One, Ruth Graham's work. This is an international study. It was done through MIT, but it was really global. And she's arguing that the future of the field is to put students at the center and use resources to facilitate team projects and authentic experiences. Earlier this year, well, I think it was last month, the National Academies published Transforming Undergraduate STEM Education. And, argue that studies are clear that student-centered instructional practices are more effective. So again, the reports and the data are there.